I'm going to be modelling chunking division strategy using the calculation 145 divided by 5. I will be using an empty number line, Numicon and a whiteboard to help me with my representations. I have chosen to demonstrate this division strategy with the use of an empty number line, which I should start by drawing now. As you can see, I'm drawing my number line vertically rather than horizontally. This is because the chunking method uses the inverse of multiplication structure and the idea of repeated subtraction. Therefore, if we place a 0 on the end of our number line at the bottom and 145 towards the top of our number line, which is our dividend, the number we are dividing into, 145, then we are able to visually move in jumps down from 145 in fives until we reach 0. I have chosen to use this empty number line as my iconic representation, as it is a sophisticated tool that allows us to visually see and jump in groups of 5, as well as allowing us to see how close we are to reach our target. So first we are encouraged to think about what the question is asking us. So through this method as inverse of multiplication, we interpret the question as how many groups of 5 are there in 145, or how many groups of 5 can we make from 145. It is important to note that chunking is about grouping multiples of the divisor 5 together to make the repeated subtraction more efficient, and not sharing the 5 between sharing 145 between 5. That is a different structure altogether. It's essential that children are made aware of this because from a young age the first method of division they learn is sharing, so we must encourage alternative thinking. So now we have an understanding about what the question is asking us, we can begin to work out the process involved in the chunking method. How many groups of 5 fit into 145? On the number line, we can show our grouping with a jump along, a procedure that incorporates the idea of repeated subtraction. To answer this question, what I could do here is lots of jumps of 5 using repeated subtraction. So we would go down our number line in 5, starting from 145. So we would go to 140 and then another 5 to take us to 135 and then another 5 and so on. However, this is more effective for a smaller calculation. So when we're working with a larger calculation, it's quite inefficient, as it takes a long time before we reach our dividend, making it time consuming, and this is where chunking is more efficient. So what we will do, instead of hopping in one group of 5 at a time, we will use our times table knowledge and facts to group in chunks of 5 together, and in turn make the process of repeated subtraction speed up. So we can do here, it's a good idea to make a small times table fact box of what we already know about multiples of our divisor. So we can think, we know that 5 times 10 is 50, and we also would know that 5 times 2 is 10. So we've got our 2 simple multiplications there. So we can look at our number line now and our times table box and know that we can take a jump of 50 to start with to make a more efficient bigger jump towards our 0 that we need to reach. So we will do a step of 50, so we'll write that in there to remind us how many we're doing, and alongside of our number line representation we are going to write symbolically 145, our informal written method here. So we're going to take away 50 from there, so that will give us 95. So here we know down on the number line we can see clearly that we've gone down 50, which takes us to 95. So now what I'm going to do is, using our Numicon as our inactive representation, we are going to put down 10 groups of 5. We're not putting down 5 groups of 10, as what we are doing is trying to see how many 5s go into 145, if that's awesome. So here we go. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, so what we can do now is see that we can do another 50, group of 50 from the 95. So I would write it on here. So we want to take away 50 from 95, which gives us 45. So we're going to do another jump of 50, which brings us to 45. So we'll place some more Numicon down. The Numicon is an effective resource to use because it allows children to understand the concept of quantity. And this inactive concrete resource allows opportunities for children to interact and manipulate, assisting children in understanding the concept and give physical and mental understanding of quantity. 1, 2, 3, 4, 5, 6. There we go. So we can do that. So now looking at our number line, we can see that if we were to take away another 50, we would overshoot our target of 0. So we need to consider a smaller multiple of 5. Looking at our fact box here, we can see that this one here, 5 times 2 is 10. So we could do that one, or we could consider looking at half of 5 times 10 to find out what 5 times 5 would be. So if 5 times 10 is 50, which it says up in our fact box, then we can see that half of 10 is 5, so therefore 5 times 5 would be half of 5 times 10. So half of 50 is 25. So that makes quite an effective jump here. So we could take away 25 from 45 and get 20. So we can do a jump of 25 here, and we've got 20 here. So we'll place 5 Numicon because that's what we have times by 5 to get here. So now we've got these here. By placing the correct amount of 5 Numicon by each jump will help understanding with a clear representation of how many objects are in a collection. In this case, how many 5s are in 145. So what we can do with our 20 now is look in our box and see that we've got, we can take away another 10, because we know that 5 times 2 is 10, which gives us 10. So we can do that here, 10. So the number line clearly shows us that we've got 10 left to jump as well. So we can do that as well. So we'll do 10, and then take away another 10, gives us 0. That's the other 10. So there's that for us. So now what we'll have to do is we need to combine the total number of 5s that we have by looking at how many Numicon 5s we have placed all together. We can see here that we have 10 along the top here, and then we've got another 10, a 5, a 2 and 2. So we can write that on our whiteboard. So we've got 10, 5, 2 and 2. Oh, 2. So what we can do now is add these up. So we can add up, we've got 5, combine them together, which gives us 29. So here we find the answer to our calculation, our quotient, 29. These are, so there are 29 5s in 45, so 29 groups of 5 in 145. To progress from using Numicon, children can use symbolic representation to show their jumps and groupings, and then once they're confident with quantity value, they can progress to not needing the visual representation by using and applying their knowledge of times tables and quantity values of groups. They can successfully complete the calculation. So they will get that out of the way. So what they would just do next to each one is write how many. So they've got 5 lots of 10 here, 5 lots of 10 here, 5 lots of 5, 5 lots of 2 and 5 lots of 2, and then they can just add it up here without the use of Numicon.